Good morning all. Today we're going to test this Eco Drive from Indramat. It's part number DKC11.1-040-7-FW. Okay, we're going to power up the control. We've applied from that external power supply plus 24 volts to pin 1 of X4 and ground from that 24 volt power supply to pin 4 of the X4 connector. And the drive powers up to BB, base block. Now that is if all is okay. When we apply the line voltage of 380 volts AC 3-phase to L1, L2, and L3, BB will change to AB. Let's go do that. There we go. We have AB in the display. Now, to run this motor, we're going to connect that external plus 24 volts to X4 pin 2, the RF input. Let's go ahead and do that. We're going to jump plus 24 to pin 2. Now the display changed from AB to AH. And next we're going to connect that plus 24 volts DC to the AH terminal, X4 pin 3. And the motor will start to run. There we go. We're running. A speed reference is applied to the X3 connector on terminals 1 and 2. I have plus or minus 10 volts from that power supply over there going to this potentiometer with ground of that power supply connected to pin 2 of the X3 connector. And the potentiometer wiper connected to pin 1. You see I'm increasing a more negative voltage on pin 1 with the potentiometer, and we're moving faster in the counterclockwise direction. Now we're going to go back the other way by applying a positive voltage to pin 1 of the X3 connector. Now we're going clockwise. Counterclockwise, clockwise, counterclockwise, clockwise. Very sweet. Now for the motor thermal, I have a 100 ohm resistor tied to pins 1 and 2 of, is that X6? I can't see up underneath the connector. I think this is the X6 connector right here. X5 is the resolver feedback. And here the motor windings are connected to, of U, V, and W. They're connected to A1, A2, and A3. That's a good run and drive we have here. Now let's try to induce some errors so that in the future, if we see that error, we will have a history of what caused it. First thing we're going to do is we're going to create an overheat situation. Let's enable the drive to run. We have AF in the display. That means we're running. Now I'm going to remove this 100 ohm resistor to simulate a motor overheating. This motor thermal warning. This is the motor thermal fault. There's the feedback fault. Motor encoder failure. Let's disconnect that again, and we'll power up. C211. Invalid feedback data. Okay, now we're going to lower to 24 volts DC. Plus 24 volt error. Let's bring that back up. Cycle power to the control. Just turned off the 380 volts AC 3-phase from L1, L2, and L3. There's BB. Now what BB actually means, ready to operate. You have BB, ready to operate, AB, drive ready, AH, drive halt, and AF, drive enable. There's BB. Now when I turn the line back on, it'll go to AB. Alright, I'm going to jump X4, terminal 2, to plus 24. There's AH. I'm going to jump X4, Terminal 3 to plus 24. There's AF, and the motor's running. Evening all. Here we are at the house. Now we got to kind of hurry up a little bit because we got a storm coming at us. A storm that might wipe us off the face of the earth. Okay. So this is the hookups so that you can run your Indramat Eco Drive. And the hookups are very much identical to your Indramat DDSO3 and DDSO2 drives. Up here on the X3 connector, we have the E1 and the E2 terminal. And I have a potentiometer whose wings are set to plus 10 volts and minus 10 volts, and whose wiper goes to pin 1 of the X3 connector. Ground of that power supply, this is a DC power supply, going to pin 2. And when I increase this voltage on pin 1 up to 10 volts, the motor runs clockwise. And when I decrease that voltage down to a negative 10 volts, that motor runs counterclockwise. And based upon the voltage from a 0 in the middle up to 10 volts and 0 in the middle down to minus 10 volts, in between there the motor will run either slow or fast depending on the amplitude on pin 1, either positive or negative. To enable the drive to go, there's 2 inputs you have to make. To power up the control, let me back up a little bit. To power up the control, you have to apply plus 24 volts to pin 1 of the X4 connector and ground to pin 4 of the X4 connector. This connector being on the left side and this connector being on the right side if the drive was standing on the upright on the wall. So when the control comes up, if you do not have the line applied yet, the 7-segment display will display BB. So with the line voltage not applied, but the control voltage applied. Now we get to the line voltage down here in a little bit. But let's say we did have the line voltage applied to that drive on L1, L2, and L3 of the X8 connector. The drive will display AB in the display. It'll go from BB to AB, and you'll hear the pre-charge relay energize. It'll go click, just like that. So we have AB in the display. When we close the RF input on X4 pin 2 to plus 24 volts, the display will go to from AB to AH, and then when we close pin 3 of the X4 connector up to plus 24 volts, it will go from AH to AF, and the motor will start to run in either clockwise or counterclockwise, depending on the voltage on E1 reference to E2. Here on the X6 terminal, the X6 connector, I've connected a 100 ohm quarter watt resistor on pins 1 and 2. That's your motor thermal plus and your motor thermal minus. Here on the X7 connector, we have our servo motor. Now it's a MKD series servo motor, and that connects to 1, 2, and 3. A1, A2, and A3. That would be U, V, and W from the servo motor. Down here on the line, L1, L2, and L3 on 1, 2, and 3. 4 on each connector is frame ground. On L1, L2, and L3, I applied 380 volts AC 3-phase, but you can apply anywhere from 380 volts AC to 480 volts AC 3-phase. Let's go look at the resolver connections. Here are the resolver connections. Now, in the back of the motor, there's a blue connector. It's 10 pin. I'll show you that in just a little bit. But pin 5 of the DB15M connector. This is the cable. On the drive, it's a female connector, DB15 female. So we have R1, that's our excitation voltage. I'm not sure what FS is, but it goes from 14 to 2. R1 goes from 5 to pin 1 of that blue connector. This is the back of the motor. S1 on pin 9 goes to 3. And this is serial clock. 7 goes to 4. S3 on pin 2 of the DB15 connector goes to 5 on the back of the motor, pin 5. Serial data in on 15 of the DB15 connector goes to pin 6 of the motor connector. S2, pin 10, goes to pin 7 of the motor connector. Serial data out, 8, goes to 8 on the motor connector. S4 goes to pin 3 of the DB15 connector, and that connects to pin 9 of the motor. And R1 here on the DB15 connector 12 goes to pin 10 on the motor. Now R1 here is excitation voltage. S1 and S3 are the cosine connections. S2 and S4 are the sine connections. Now let's go over and we will look at that connector on the motor. Here's the feedback connector on the motor. And down here, let's get oriented. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now down here is the back of the motor, and up there is toward the shaft of the motor. So if we were looking down on this connector, that would be the orientation. Now, on pin 1 and pin 10, that is the rotating transformer of the resolver. That's where your excitation voltage would be applied. On 3 and 5, that's our cosine winding of the resolver. And on 7 and 9, that's the sine winding of the resolver. I don't know what FS is. If y'all could tell me what FS is, I would really appreciate it. Now on 4, we have serial clock. On 6, serial data in. On 8, serial data out. There's communications between that feedback of that motor and the drive. So the drive talks to the feedback device, and the feedback device talks to the drive. Now down here on 3 and 5, I measured 160 ohms thereabouts. On 7 and 9, I measured about 160 ohms. You can actually put your meter on there and measure those resistances to make sure it's not opened up. And on 1 to 10, I think I measured between 40 and 50 ohms thereabouts. But there you go. That's the feedback device on the motor. Now I'm going to go in the backyard and I'm going to feed those birds. We got to take care of those birds. Something we've been doing for many years. And I want you all to be safe these next couple of days because we got a hard storm coming in here. It's going to wipe us off the face of the earth. If you can, find shelter. And don't be getting out in that mess. I'd like to see you in the next video if I could. Well, good night all. Be careful out there. And we'll see you in the next one.